So now let's get coding. All right. So the first thing I want to do is import. Let's do from typing import list. Okay. This is typing is a module for um um type hints. Okay. So want to make sure we're type checking our variables. Okay. So the next thing we're going to do is define IOU, and this function will take two bounding boxes. So we'll do bounding box 1, which is of type list of int, okay? And we'll take bounding box 2, same type list of int. And this function would return a float. Okay, so remember, I told you intersection of a union is area of intersection divided by area of union. So the first thing I like to do to make the coding very clear and for you to understand, I can access this each item in the bounding box directly, but I want to unpack it so you can see what we're doing. All right. So the first thing I like to do is unpack each of the bounding boxes. Remember, each bounding box has x1, y1, x2, and y2. Okay. So let's get unpacking. So I will do BB box 1, x1, BB box 1, y1. I'm just going to copy, okay? So we don't have to type it again. And we'll change this to x2 and change this to y2, all right? And then we'll unpack it. So we unpack by indexing the bounding boxes, okay? So we'll do bounding box 0 will give us x1, all right? And I'm just going to copy it. So save time. So we'll just change the number, the indexes, okay? So this will be 1, and that would be 2, and this will be 3. So we've unpacked the bounding box for the first bounding box. So I'm going to do the same for the second one, right? So let's do the second one. Okay. And I'm just going to change this to 2, to 2. So this will be 2, 2, 2, 2. Alrighty. So the first thing we're going to calculate is area of intersection. All right. And we're going to want to do the width. Let's comment this. We'll do width. So let's do start width equal to, remember, it's the maximum between BB box X1 and BB box 2's X1, okay? So that will give us the start width. So where the intersection starts from, all right? As far as the width, all right? As far as the x-axis, right? So we'll do the same thing. We'll check for the end, all right? End width. This time it will be the minimum. Remember when I explained on the whiteboard, right? So it's going to be the minimum between the x2s, all right? So I'm just going to copy this and change to x2, okay? This will be x2, x2, all right. Okay, then the width will be, so because we don't want to have a negative width, we'll do the maximum between 0 and end width minus start width. Okay, so now we're going to do the same thing for the height, the y axis, the y coordinates. So what I'm going to do, I'm just going to copy all of this and just change things up. Okay, so this will be the height. Let's change this to height. Copy that. Change this to height. And this will be y1, y1, y2, and y2. All right. So we get height equal to the same thing that we did here. We don't want a negative height, so we'll do the maximum between 0 and the height. So remember, height is 0. So we'll do end height, start height. Okay. So if this is a negative value, the height becomes 0. So this is just edge cases, all right? So now we can do the area of intersection. So we can do area of intersection equal to width times height. Okay, so now we've gotten the area of intersection. So let's calculate the area of union. Remember, the formula for that is area of bounding box 1 plus area of bounding box 2 minus area of intersection. Okay, so the first thing we're going to calculate now is the area of each of the bounding boxes. So let's start with calculating the area for bounding box 1. So we'll do area BB box 1 will be equal to we'll do the x-axis to get the width. So we'll do BB box 1 x2 minus BB box 1 x1, okay, times BB box 1 y2, yep, y2 minus BB box 1 y1. So that will give us the area for bounding box 1. So we'll do the same thing for bounding box 2. I'm just going to copy and paste, okay? And then I'll change things up like so. 2 here, 2 here, and 2 here, okay? Make sure that is correct. And then we can now calculate the final area of union. So this will be plus that minus this, okay? So if for any reason, right, if for any reason this area of union is equal to 0, we just want to return 0.0, okay? That means there's no overlap. Remember when I showed you on the whiteboard? It means there's no overlap. Otherwise, we want to return area of intersection divided by area of union, okay? Or we can just put this in a variable. It doesn't really matter. We can do IOU equal to this, right? And then we'll just return IOU for clearer coding, okay? So you can understand. And yeah, that is all for intersection over union. So the next thing we're going to code is non-maximum suppression. But first, let's run this to make sure we have no syntax errors, okay? So let's run this. And yeah, there's no syntax error for this. So let's code non-maximum suppression.